Hi, today we're carrying on with some more complex trig equations. The thing to look for here is the potential middle term of your quadratic equation. Clearly this is going to be a quadratic because we've got a cos squared, but now I want my quadratic to go sine squared, sine, and a constant. So I'm going to replace this cos squared x with a 1 minus sine squared x plus that 5 sine x is equal to 4. Tidying up my quadratic, I get 2 minus 2 sine squared x plus 5 sine x is equal to 4. So naught is going to equal 2 sine squared x minus 5 sine x, and 4 minus 2 is going to give me a plus 2. Factorizing my quadratic equation, it's going to be 2 sine x and a sine x. I'm going to have a 2 over here, I'm going to have a 1 over here. When I multiply out there, I'm going to get a minus 4 sine x, a minus 1 sine x, which is going to give me a minus 5 sine x. Once you have a product equals 0, we get that sine x is equal to a half, or sine x is equal to 2. Sine x equals a half means that my x value is going to be 30 arc sine of a half plus k 360, or my x value is going to be 180 minus 30, 150 plus k 360. On this side over there, when you try and take arc sine of 2, you're going to see math error. That's because sine has a maximum value of 1. So there, on this side, there is no solution. Don't forget always to add that k is an element of the set of integers. All right, the next question I've chosen to do, again it's going to be a quadratic. You've got a sine squared x, but now your potential middle term is going to have a cos x. So that means I want to replace the sine squared term with a 1 minus cos squared x. When I multiply out my bracket, I get minus 2, minus times a minus is a plus 2, cos squared x is equal to cos x. This means that 2 cos squared x minus cos x, okay, bringing that over, 1 minus 2 is minus 1 is equal to 0. When I factorize that, I'm going to get 2 cos x and a 1. I want that to be a minus, that to be a plus. Minus 2 cos x plus cos x will give me that minus cos x term there. So here I get that cos x is equal to minus a half, or cos x is equal to 1. When I solve a cos trig equation, arc cos of minus a half is going to be 120 degrees. So I get x is plus or minus 120 degrees plus k 360. Here arc cos of 0 is going to equal 1. Cos of 0 is 1. So my x value here will be 0 plus minus 0 plus k 360. Obviously you don't have to write in that 0. And again, k is an element of the set of integers. Now the last quadratic I've chosen to do is going to have a middle term of sine x cos x. So that means in the sum I need both a cos squared and a sine squared term. That means I'm going to say that this becomes 2 times sine squared x plus cos squared x minus sine x cos x minus 3 cos squared x is equal to 0. this becomes 2 sine squared x plus 2 cos squared x minus sine x cos x minus 3 cos squared x equals 0. 2 sine squared x minus sine x cos x. 2 of them minus 3 of them gives me minus cos squared x, and that is equal to 0. When I factorize this, I get 2 sine x and a cos x. Here I have a sine x and a cos x. I want to land up with a minus 2 sine x cos x and a plus sine x cos x to get that middle term over there. This means that 2 sine x plus cos x is equal to 0. 2 sine x is equal to minus cos x. I need one trig ratio out of this, so I'm going to divide both sides of this equation by cos x. So I land up with 2 tan x is equal to minus 1. Tan x is equal to minus a half. When I solve that, arctan of minus a half, that is not a special angle, so I need to work it out. Arctan of minus a half is going to be minus 26,57 plus K 180. On this side over here, I get that sine x minus cos x is going to equal 0. So sine x is equal to cos x. So tan x is equal to 1, and x is equal to 45 plus K 180, where K is an element of the set of integers. Okay, so the trick in all of these quadratic trig equations is to look at the potential middle term and do a substitution using that identity that says sine squared theta plus cos squared theta is 1. I'd like you please now to do these examples from Classroom Mathematics, exercise 5.2 on page 131, 2, 6, 8 and 12. Thanks very much.